Today we're going to be talking about inequalities. First of all, let's identify what is an inequality. So we have two key words here. Our first word is linear with the root word line, and that's telling us that when we graph this, it's going to form a line. Our second key root word here is unequal, meaning not equal. So that means we're not going to see any equal signs in these problems. Okay, so the next question is, if we're not going to see equal signs, what are we going to see? Let's take a look. So these are the symbols we're looking for in these in our inequality problems. We're going to see less than symbols. And remember that a less than sign is just saying that whatever is over here on the left is less than whatever is here on the right. We're going to see a greater than symbol, which is saying the opposite of the previous one. So it's saying whatever is over here on the left is greater than whatever is over here on the right. And we need to be sure that you can read these in a sentence, like a math sentence. So when we write down our inequality, this is read as x plus 8 is greater than 10. Okay? And it's really important that you can read that in a sentence. I know that a lot of elementary school teachers just teach this as the alligator mouth opens to the bigger number, and that's fine when you're in elementary school and all you're dealing with are numbers, but it gets a little bit more confusing when you have something like x plus 8 over on one side. So it's really important that you can read that as either a greater than or less than symbol, depending on which direction it's facing. We also have down here at the bottom two symbols that look like the ones at the top, only they have a line underneath them, and that line underneath them tells us that these are going to be less than or equal to. The line on the bottom is the or equal to part. Okay. Or the second one is greater than or equal to. And hopefully when you're looking at these, this isn't all brand new information. Hopefully this sounds vaguely familiar. It's something that you've heard before, and this is just a little bit of a review. If it's not, you probably want to come into 0 hour to get some extra help. Okay, so let's look at some similarities and differences between a linear inequality and a linear equation that we looked at in the last section of this chapter. So remember that linear inequalities and linear equations are both going to be similar in a lot of ways. In fact, they're more similar than they are different. So they still follow the same order of operations. You still have to use PEMDAS. And you're still going to go through the same steps that you would to solve for a linear equation. So you're still trying to get the variable by itself. That's still the goal. So get the variable alone. You are still going to have variables in there, and you still have to follow the same opposite operations rules that we talked about in the last section. Okay, so if you have something, oops, can't spell there. Operations. So if you have something like x plus 8 is greater than 10, remember our opposite operations say that because this is a plus 8, we're subtracting 8 on both sides. So that part has not changed at all. Okay? That would still be the exact same. So what is different? We do have a few differences. All right, so one of the major differences is going to be in the graphs. Okay? And so you're going to notice that graphs of inequalities are going to have, sometimes they're going to have dashed lines on them. They're usually going to have some shading, okay, either above or below the line that was graphed. And we'll talk a little bit more about those in class and look at some examples and what those graphs mean. But you just need to know right now that the graphs can be different, including things like they're going to have shading and they may have dashed lines and, instead of solid lines. They don't have to, but they might. other key difference that's going to be important as we're solving these is when you divide by a negative number. Okay? So when you divide by a negative number, okay, when you do that, on an equal sign, nothing happens. You just keep on working. But when you're doing this on an inequality, you have to switch the sign. So if you divide by a negative number, you switch the sign, or switch the symbol, might be easier to say. And we're going to look at some examples of those in just a minute. But we're saying that if it was a greater than sign before, once you divide by a negative number, okay, then you are switching this sign around. So it would become a less than sign now. Okay, like I said, we're about to look at some examples, so give me just a second. Okay, so let's start with one that's very similar to what we were doing before. On here I have x minus 15 is less than 13. I want the x by itself, so I'm trying to get rid of this negative 15. Now the negative 15 is just x minus 15, so I just have to use my opposite operations. So the opposite of subtracting is adding, so I'm going to add 15 to both sides. And negative 15 plus 15 is 0, so those cancel out. And so I'm left with x is less than 28. So it's a funny looking less than sign. There we go. And so that is my final answer. I don't have to do any more work on that one. Okay? Remember, on this one, I just had minus 15, so I did not divide by negative. So you'll notice here, my sign is a less than in the original problem, and it is a less than in the final problem. Okay? Let's look at another example. Okay, in this example, we have to do some dividing. Because remember, this 7n, that's really 7 times n. So when those are multiplied, in order to get rid of the 7, because we want the n by itself, we have to do our opposite operation. So the opposite of multiplying is dividing. So I'm going to divide by 7 on both sides. And when I do that, 7 divided by 7 becomes 1. Still have my n. And I divided by a positive number. The 7 is not negative, it's positive. So my sign, or my symbol, excuse me, here, stays the same. And I do 42 divided by 7 is 6. And again, notice, because I did not divide by negative, my symbols here are facing the same way. They're both greater than symbols. Okay? Let's look at another example. Okay. On this example, I have negative 4, times d, because remember, negative 4d, there's an understood multiply sign there. And so in order to get d by itself, I am dividing by negative 4. Whatever I do to one side, I have to do to the other. And notice, this time, I am dividing by a negative number. So this symbol here is a less than sign in the original problem, and so I have to switch it around. Now, when I divide negative 4 by negative 4, those cancel out. I just am left with 1. So I have 1d, and 28 divided by negative 4 is going to be negative 7. So notice that unlike the other problems that we did, because we divided by a negative, our symbol here switched from a less than sign up here to a greater than sign down here. Now, some of you are wondering, do I have to have that 1 in front of the d? No, you don't. So you can also write that just as d is greater than negative 7. Okay. Also, just in case any of you were wondering about the 28 divided by negative 4 and how the signs work on that, remember that when you're multiplying and dividing, if you have the same signs, then your answer is going to be positive. If you have different signs, then your answer will be negative. And that's just for multiplying and dividing with negative numbers. Okay? Let's get one more example. Okay, our first step on this one is to get all of the y's on the same side of the inequality. Now, it doesn't matter which side you move them to, but I usually move mine to the left. So I'm going to subtract 9y here. Remember, if I'm subtracting, nothing happens to the less than or equal to sign. It stays the same. Okay, so I have 6 minus 9y. And if you're not sure about how to add and subtract with your negative numbers, you might want to go back and look at my YouTube video about adding and subtracting with negative numbers. It has a fun little song to help you remember the rules. So the big rule is if they have different signs, which they do, because this 6 is an understood positive, because it's not labeled with anything. So I have different signs, so I'm going to subtract. So 9 minus 6 is 3. And then I'm going to keep the sign of the bigger number. So 9 is bigger than 6, so I'm going to keep the sign of the bigger number. Okay? And then I just bring down everything else that was in the equation. Oops. And it is a positive 2, but you don't actually need your plus sign there, sorry. Okay? Now we want the y by itself, so we have to start moving things away from the y. So I have a negative 8 here, so I'm going to go with my opposite operation. So the opposite of subtracting is adding. So I'm adding 8 to both sides. And negative 8 plus 8 will cancel out, so let's go away. And then 2 plus 8 over here is 10. All right? Last, I have this negative 3 times y. And so on here, these are multiplied, so I have to do the opposite, which is going to be divide. So I'm dividing by negative 3 on both sides. Right? And negative 3 divided by negative 3 is going to be 1. So I have 1y. And remember that in this step, I divided by a negative number. So my symbol here is changing direction. So it was a less than or equal to. Now it is a greater than or equal to. So notice it doesn't matter that it has a little equal sign underneath it. Just the top part is going to flip around. I still have that little equal sign under there. Last, but certainly not least, is the negative 10/3 here. Couple of things to say about that. First of all, if your book doesn't say anything else, then by all means just leave it as a fraction. Second of all, I always get at least 1 or 2 students who are curious about whether it matters where that negative sign goes, and the answer is no, it doesn't. And so if you have negative 10 over 3, or the negative sign where it looks like it lines up exactly with the little division sign, or positive 10 divided by negative 3, all of those are exactly the same thing. So I'm going to make you a list over here. We have negative 10 over 3, negative 10/3 like this, and 10 over negative 3. All 3 of these things are exactly the same. So it doesn't matter which of these ways you write your answer. Those are all going to equal exactly the same thing. Also, unless it asks you to round, there's no reason to type this in your calculator and get a decimal. So just leave it as a fraction. I hope that this has been helpful. If you have any questions, feel free to come and see me during 0 hour. Otherwise, I hope you have a wonderful day, and thank you for watching.